Assalamualaikum warahmatullahi wabarakatuh. Today, me and my group will present our project. Our project title is Find Mass and Center of Mass for Laminar. First, let me introduce myself. My name is Muhammad Farhanuddin bin Mawazil, and my group mate is Akhtar Kumar, Chan Chen Yu, Kamalu Akbar, Azri, and Farhan Aiman. Okay, I will present introduction of our project. What is lamina? Lamina can be defined as a two-dimensional segment taken out of a given object to make measurements simpler. Lamina have a mass or weight even though their thickness are negligible. Regardless of the shape, a lamina is found to be one of numerous uses in both mathematical and natural regards. What is center of mass? The center of mass is also known as the center of gravity if the object is in a uniform gravitational field. If the object has a uniform density, the center of mass is the geometric center of the object, which is called the centroid. Formula used to find the mass and the center of mass for lamina. There are formula we use to develop the calculation. Formula we use. The first formula we use is to find mass the mass. The second formula is used to define the center of mass. The third formula used to find the coordinate of the centroid.
Assalamualaikum and hi Dr. Amani. My name is Atakullah bin Abu Zahrim. My metric number is CF190195. I will present about our problem statement and fila tables of our mass and center of mass of Laminar project. According to the diagram on the right side, we can relate the situation in real life where a carpenter need to find the centroid of the table as the center of gravity of the table so the table will be balanced and stable to use. In our fila table, the facts for the project contents are centroid is the center of mass of 2D lamina or 3D solid. Centroid is a solid is the point which the solid will balance. The ideas for the project are to find laminar density, to find moment y-axis and x-axis, to find coordinate of the centroid. Our learning issues of the project are how to determine the equation, how to compute the center of mass, and how to compute the coordinate of centroid. To solve all these issues, our actions are to use the specific formula where my group members will present on the next slide. That's all from me. Thank you for watching.
My name is Chan Chunyu, metric is CF190190, and today I want to present about the methodology. So this chapter describes the methods and calculations used in solving problems as stated in the problem statement. This is intended to explain how the study was conducted and to obtain accurate information. The calculations are set up by using a double integral equation. This is because double integrals are used to calculate the area of region, the volume under a surface, and the average value of a function of two variables over a rectangular region. So this is the mass calculation and we get 281103.333 kilo. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Kamal Abraham Osman and my metric number is AF190076. Okay, now I will explain about the moment of mass. Okay, after we get the value of mass which is m, we must find the moment of mass. This is because the moment of mass can help us to find the center of mass, which is we can get the coordination or something like that to answer this question. So before we find the moment of mass, we need to find the moment of mass in two axes, which are in y-axis and x-axis. We need to use the double integration method. Also we need to use the limit that we got from the equation. Okay, first we need to find the moment of mass in y-axis. So this is the equation. Okay, we do the double integration method in this y-axis, so we can get the answer for y-axis is 182.53408.33. After we get this answer, we get the moment of mass for y-axis. We can after we get the moment of mass for y-axis, we need to find the moment of mass for x-axis. So we still use the double integration method and solve the equation. So we can get the moment of mass for x-axis, which are 702.7604.45833. So after we get the moment of mass for x-axis and y-axis, we can continue to find the center of mass. Okay, thank you.
Hello guys, Assalamualaikum. My name is Muhammad Farhan Aiman bin Tazali. My matrix number is AF190202. So here I am today explaining about the center of mass. You need to use the formula of center of mass, which is as you can see, and then you need to substitute the my value with the moment of mass formula, and then you will get also the ms formula and also the m formula. And then you will get the coordinate, and then from the value of x and y, which is the coordinate, you need to find the centroid, the coordinate of the centroid, sorry, which is to find the coordinate of the centroid. First you need to find the area, which is from these equations we use the triangular area, so we need to use the half multiple with 130 multiple with 100, we got 6,500 square centimeter. Alright, and then the y value equal to y over 2. This y means the we need to differentiate it. Okay, and then to find the qx, we need to integrate the y dA, and we integrate and then you solve it by yourself, and then you will get the 21666.6667 centimeter cube. And then from the answer, you can find the value of y, which is with the line below, which is y with the line below equal to qx over a, which is the value of a is the area of the triangle. Alright, so by substituting that, you will get 33.33 centimeter. Right, then after all, to find the x value, you need to use the qy. Then qy, you integrate it with x dA. After all, you solve it, you will get 28166.667 centimeter cube. And then with this answer, you need to substitute it with the equation of x, which is qy over a, and then as usual you use the same area, and then you will get 43.33 centimeter. Alright, so yeah, thank you.
So for the result and conclusion, in conclusion, the calculators know how the dimension of the flat surface of the right angle triangular table is based of 130 cm and the height of 100 cm. So after the calculation, the calculator should be able to find out the mass of the table, which is 28 kg. So if we want to make the right angle triangular table with one leg, we must put 43.33 cm from the left corner of the table and rush it 33.33 cm to the center of the table. Therefore, the carpenter should be able to design the table with one leg and stabilize it. So that's all from us. Thank you.